You can see this is our contractor 6.0 pot with electric controls. So we're gonna kind of go through this pot. I think we did it on the screen. You see the incoming air. You can step over here and look. See the incoming air. You got the air dryer. And you got the Millennium valve. And you got the cage around it to protect all these components. This is an electric control panel. It's typically closed in the field. It's sealed to protect it. So the way this works, and we're going to hook it up and troubleshoot it in a minute, is we need an air signal to trigger these valves. They're pneumatic valves, but we're going to use, since we're going to be 100 foot away plus, we're going to use an electric signal to get a quicker response. This particular electric version is a 110 volt, but we do offer a 12 volt version as well. So this cord gets plugged into your power. So this is incoming power right here. Should be live. And then it's going to come in right here, and it's going to be distributed out to the dead man. This is an electric dead man with an ACS switch, abrasive cutoff switch, which is actually a little hidden, but it's right in here, protected. So this is our standard dead man, but instead of pneumatic, it's an electric version. It's got a little replaceable switch in here, but it still looks like our dead man. We're going to troubleshoot this because there's a couple ways you can find out, you know, what's working and what's not if they have a problem in the field. So what we want to do is...
Ready for air?
Yep. Turn on some air. And we're going to test it. All right, so we got that. Let's trigger it and make sure it works. We also put this is a neat little trick. We put a little paper clip right there in the quantum valve. This is an auto quantum valve, so that'll give you the ability to cut off abrasive and just blast with air. You can blow off parts. After you blast, you can clean out the hose of any abrasive with air, which is nice to get all that abrasive out of the hose. Ready? See, look at that paper clip. Oh. It's probably the loudest part. Let's try it again. See how it dropped down and then raised back up? What was that? Now it's going to depressurize. What was that? All right, so what we've got here is you got incoming power and you got two solenoids. And one way to test this is we've got a little button on the end of the solenoid, and you could just press it to see if it actuates. One solenoid, this top solenoid, actuates the blast pot. So if you follow the air, and that's really what it's all about, is following the air. You got air coming in. Actually, this is a dryer system. So you got air coming in to supply the two valves. The electrics actuate the solenoid. So the first solenoid is actuated by this trigger. The second solenoid is actuated by this trigger. So you got air coming in, it comes to the solenoid and waits. And then if the first solenoid is triggered with the electrical signal, it'll go on. And you can see it tees off right here. So this blue one goes to the second solenoid. The orange one continues on to this. So if you follow this, that continues on to the Millennium valve. So when you hit that trigger, this solenoid's trigger, air comes here and waits, and it also activates the Millennium valve. So you're blasting. So then where does this one go? Well, air comes here and waits until this switch is either in the on or off position. If it's off, it doesn't continue. If it's on, it continues on to open this valve. So if we do this, we'll probably see, and we trigger it. Watch above you. I'm going to stand back here so I don't get showered. Got air on. Let's see if that paper clip pops up. Doesn't even pop up because I switched the abrasive off. Okay, so now if you had a blast hose nozzle out there, you'd just be blasting with air. And you could do that. You could do that at the nozzle. Switch abrasive on and off while you're holding the blast hose. So there it is. Let's see. We should have an air signal. Careful. How that work? I activated it just by pressing that button. So then you can test whether or not that solenoid's good if you have a call saying, hey, you know, this electric pot doesn't work. What's going on? Can you help me? That's one test. This is the other one, is just the abrasive version of it. You got to do both. Yeah.
You can hear it exhausting through your exhaust port here.
Yeah, this other green one is just an exhaust valve for these solenoids to relieve the air pressure. I think we're good. So that is our electric controls. This comes in 12 volt or 110 volt like we have it here. So if you're in the field and you have a compressor, a lot of compressors have a 110 volt outlet that you can plug into. You know, or you can run it 12 volt off the battery.
Bobby, what's it switched out here for again?
This controls the media valve, so it shuts it on and off.
Okay, so when you switch it off, then you're just blowing with air.
Yep.
You switch it on, that's when the valve opens up and the media comes out.
Yeah. So what a lot of contractors do is they're gonna start blasting with it on, blast a bunch of stuff, and then they will blow it off. Because then, you know, it's one step closer to paint. You can also clean the abrasive out of your blast hose by shutting it off. You can move abrasive, say you're in a blast room and your recovery is at that end. You can use it to just blow all the abrasive to the recovery point so it can get back and feed your hopper and pot.
Okay. What setup? I probably went. I got up here late. What setup is this? This is
the contractor 6.0 contractor with the electric 110 volt electric remotes.
So as far as the valves, we've got the Quantum.
Yeah, we got the Auto Quantum, and the Millennium.
And the Millennium. Okay.
The other thing is, one other thing.
Because the Millennium really is a remote system, right? Basically?
It's an inlet and outlet valve in the same valve.
Your remote, whereas this is a metering valve. That meters the abrasive. This is basically
this is your
air.
remote controls,
Okay.
and that's your abrasive metering.
That's where I was getting a little confusing with the product line, to be honest with you. But.
This is the other thing, I think we talked about it in, is this little pepcock here. Right here is kind of a safety pepcock. If you turn this open, you're gonna stop blast from happening. It can shut the whole system down just by, it's kind of a bypass, if you will. It doesn't allow the air to do what it needs to do to turn the blast pot on.
And this is still considered a pressure release system, correct?
This is a pressure. Well,
This is a pressure release.
Yeah.
Okay.
Correct.
Yep.
Well, I think, and for me, as long as I still get confused on, especially with, you know, certain systems like this system, it can be sometimes confusing because
Yeah.
I've always, as far as knowing in my head, okay, if I've got air going into the metering valve, that's pressure hold.
Yeah.
Well,
That's
it
why it's
isn't with your
confusing.
system, right? I mean, it is with some of the other systems.
Any pressure hold system is going to be something that you have to manually depressurize. So if you're not letting off the handle and it's depressurizing, if you've got to come over here and turn a ball valve or you've got to flip a switch, that's considered a pressure hold system. It's going to hold pressure in the machine until you come over.
But just identifying that system
Sure.
in a quick way. I walk up, like I said, usually, because I would, but
The quickest way to identify it is you'll have a valve in your pusher line that's controlled pneumatically. So that would be the
yeah,
quickest
like
way
the
to
auto
identify.
air valve. Okay,
Mhm.
yeah, that's a good way too. Because this really replaces your inlet outlet valve.
Correct.
I mean, versus the old traditional. Again, that's where again how you view it, how you think about it. And,
Yeah,
Sure.
we combined them into one
no,
valve
It's a great
there.
system. You just making sure I understand.
What's
going
this?
down. So that's your abrasive trap, isn't it?
Yep.
Yeah.
It,
That's the same on the
yeah.
other setup.
You've got them on your inlet outlet valves as well. So that's something that should be checked usually multiple times a day, but depends on your use really.
What, you have to empty it? When it gets full?
Yeah.
How do
You
you
got
do that?
pliers
You
over
just-
there?
Can you empty it just the way it's hooked up now?
Yeah. I'll show you.
I'm trying to remember. Was yours? And
Brand new.
they were saying maybe you should put some
So what happens is you have a abrasive laden air coming when you depressurize the pot, all that pressurized air has to come through here. So some of it's got abrasive. So we want to stop the abrasive before it gets here
Okay.
and destroys junk.
Okay.
So this is there to stop it, but
And then it falls underneath, or
yeah, what it does is it hits it and then comes here.
so what do you do? Do you just remove this to
Yeah,
pull
you
it
can
out?
remove that. Yep.
Okay. Deal with this.
So you've got the air going this way. Check your screen daily. You don't want a hole in that screen because if you get a hole in that screen, you're going to start getting holes in this valve.
So it's just a check daily.
Yeah, it's kind of like a, check and fix that so you don't have to check and fix this. This will last much longer. So that's the key. So you'll see that on all
Does anybody
these
ever
pots.
check that?
No,
The screen?
no. You can check them. That's what we were showing you is to push them in there and check them to see if they're operational. If they're not operational, they're not going to send the signal on.
right.
So we wouldn't have saw if this one was failed. If this failed, we would not have seen it open up that valve down there. Or if this one was failed, the pot won't pressurize because it's not sending the signal on.
So if you leave that outlet valve open and you try to pressurize the pot, it'll just shoot out the back, right?
Right. That petcock with it open, all your controller.
Where does it come out again? Is it right here? Does it come out of here?
So yeah, if you have this one's a little tight, but if this is open, all your control air that's coming in through these lines is going to come straight out here. It's going to bypass this. So any leak in this system is going to cause this system not to activate properly.
Okay.
So this is going to be considered a major leak and it won't activate the Millennium valve. So that's a good way if you're working on the machine, you come over here and you open that petcock up so nobody can pick up the hose out there while you have this valve apart, or maybe you're working down underneath and activate that system while you're working on it.
So you can just open that up.
Yep.
And if you open it up, then there's not really any
Nothing's
risk.
going to happen. Yep.
I'm just trying to think of a scenario where this thing would be pressurized. I guess the most dangerous thing that can happen is you could start shooting when you're not ready to, right?
Right.
But it's not like something can happen with the pot when it's pressurized, because it'll either release the air.
Well,
it'll just stay
you got to
pressurized.
make sure you're within your working pressure of the vessel. So these are all rated for 150 psi. But you always want to make sure and look at that data plate. If you overpressurize them, then something could rupture or happen in that.
What do you
respect.
think would happen?
I have no
Like
idea.
something would fail and you'd
I'm just
start losing.
like, could this thing just explode because it's pressurized and
Yeah.
something happens that you mess with the valves the wrong way and it just explodes or something? I don't know.
You don't see much of that.
Yeah, I'm just trying to think of how it could happen.
Yeah. All right. I want to try and show you guys the Millennium valve. Show you how it works, what it looks like inside. So you kind of understand, you know, when you look at it, it looks complicated. It looks maybe scary to some. Doesn't look easy to understand, but really, if you follow the air, in a lot of our products, it's all about following the air. So in this instance, with the Millennium valve, the air is going to come here and wait. And the reason is, if you look at it, is this piston is normally in the closed down position. This spring keeps it in the closed down position. So air comes here and waits. It can't get past this because of this seal, right? When it does get past this, it's going to go here. It could go here, but we have a plug there, and it's going to go here to the blast line. So when this piston does go up, it's going to pressurize the pot, and it's going to go down past the media valve and out through the blast hose. So what makes that go up? The dead man makes that go up. The signal from the dead man pushes air in here and forces this to go up. The only reason why it works is because there's a series of O-rings. Some of them are directional and some of them are just O-rings that fit into a groove, like these two. So if we had a good way to figure out which O-ring was bad, that would be helpful, right? Say you're having problems with it, it'd be helpful to, you know, all right, which one am I replacing, or so you don't have to replace each one. Well, we do have that. They're little weep holes, and I get emails and calls all the time. Hey, there's a hole in this valve and it's leaking air. I want a new valve. It's, you know, it's a bad valve, a bad casting, but it's there on purpose. It's a tiny, you know what fits in there is a paper clip fits well in there, in these holes, but they're there for a reason, and they're there if there is air weeping out of there. It's a signal that something is wrong with the valve and you need to replace some parts in it. So there's 3 of these weep holes on here. This is the first one. It's for the upper seals, and these are the directional seals inside this piston. If you get air leaking out of this valve, if the unit won't operate and you're getting air leaking out this valve, there are 2 directional seals that need to be replaced, and we have a kit for that. This one it's a U-type seal, and this one is facing up, and this one is facing down. And that's air coming out of that hole is signaling that those need to be replaced. The second weep hole is on the other side, right here. So if you can imagine, that one would be the lower part of the piston, the lower seals, these O-rings right here. Those are the ones that would need to get replaced if you've got air leaking out, because air is going to come here, and if it can get past these, it's going to leak out of there. If it could get past these when you're triggering the thing, it's going to get out this upper hole right there. The third one is for the outlet or the muffler area. I believe it's on the other side. Right here. So if that one goes bad, we have a muffler rebuild kit, which is essentially a diaphragm in there. There's a diaphragm in there. There's an O-ring here. This diaphragm, it could be bad and you'll be leaking out of there. So this is kind of the Millennium valve.
Is it enough air leaking that you just held your finger there, you'd feel it?
Yeah. We'll show you in a minute. We've got examples.
Oh, I need to stop asking.
Great question. But no, good answer.
What? Yes. You can feel it with your finger, and you will get.
This
That-
system's called the Millennium Valve.
This
that
is the
correct?
Millennium valve. It's an inlet and outlet valve all in once. And this is a cutaway of the muffler portion of it. It's basically there as it exhausts, instead of just air getting,
So this
shooting
guy's the
out, this
muffler?
kind of, yeah, it kind of
Okay.
dampens it and muffles it down.
Is it only on contractor pots?
Yeah, but you can, it's put in blast room pots as well. It's used in blast room pots. You could buy the valve and,
Standard.
no, the classic is the inlet outlet valve.
And why would I want this system over the old school?
Contractors
Why would I
tend
want
to
that?
prefer a more compact
Okay.
single valve to do inlet
Instead
and
of having
outlet.
valves on the side, you have it in the back,
Yeah.
protected. Some more of that than
Yeah.
maybe even usage or user friendliness or
User
efficiency
friendly, simplicity. Still, the classic, I mean, this was, I think, born by the Schmidt Combo
Combo valve.
Micro.
I would assume.
But
that,
still, the classic outsells anything else because it's a proven system. Yeah, it's old school, but it's proven system that,
Plus, it's good parts specifics, quite frankly.
yeah,
But it is a
and
great
those
system,
the
isn't it?
inlet
Yeah.
and outlet valve
Yeah.
are, they're, you know, it's cast
Yeah.
brass, I think it is, or bronze, whatever that is. It holds up well. So now, what we want to do is troubleshoot this one, and let me see if you could guess which. Let me see if you could guess what's going on here. That doesn't sound right, does it? Look at the pop-up. That's not right.
Is it not lined up right or something?
Oh, well. Okay, so it will pressurize, right? But something's not right.
In there.
Something's not right. But it will pressurize. Watch out, I'm gonna release the pressure. Takes a long time to depressurize too, if it even will depressurize. There it goes, because I turned off the air. So where in this valve do you think it was leaking? Did anybody check a weep hole while it was? Huh?
Something on the outlet side causing problems.
On the outlet side? Because it wouldn't release pressure very quickly? Is that where you say that? What about that? That would be more on the inlet side, wouldn't it?
Not letting enough air in.
Well, it's letting some air in, and it shouldn't. be
Letting
any.
some air. What should be happening right now? No?
Ah,
So where do you think that would be? The other thing is, you can feel air. So where do you think in here, which seal do you think it's getting past? If
we gotta find where he's feeling air coming from.
there's one other seal in here that we also didn't spend a lot of time in. So air comes here and wait. How can it wait there? If the piston's down, what stops the air? Yeah, this seal right here.
So it's just not down all the way.
Worn out. Does it wear out?
Would be worn out. We can take this apart and see.
And based on what he says, it's probably the most common part.
Huh?
Make Dylan do it.
Who? Why? Have you done it?
Candace, she likes to do stuff.
All right. Yes. Let's take it apart.
Candace said she'll do it next part.
You got your air off, you got your safety glasses on, your air's off, dead over there.
Maybe I should throw this in the pot and let Chris look for it.
If the air is on and you try to fill that thing off, it could shoot off.
Like right
Well, it could, yeah. But,
No, you lose a couple volts. You lose.
I don't know. Yeah, and plus the air goes there.
He
And
turned it off up there too, but if
yeah.
there was still air going through that, if that was
The problem is what's holding it down. The spring is holding it down. So even as you release 2 bolts, it's still held down enough to create the seal. It's not until you get it off all the way that the spring releases, the seal fails. And yeah, you're right. You would get hurt.
Usually what I'll try to do is leave 2 in here opposite each other, but you're good.
You have to take them all the way
It's
off.
under a lot of pressure.
Hmm?
It's under a lot of pressure.
No, no, really. It's just. You can,
The screws come all the way out
yeah.
too? Okay.
But there's a spring back there. So you just don't want it to fly off. You get as many out as you can.
Stay in.
Hold it down. Take the last 2 out. There you go.
There should be 2, those 2 silver ones.
Where? Oh, there they are. So, to get this piston out, we're going to cheat a little, pull it, and use, what is that, 5/16?
Quarters.
Quarter inch?
You sell those screws as well? Those bolts?
I do, personally. They're $500 each. Oops. You can PayPal me. Should come out. There it is. Boom.
Yep.
It was that seal. So that seal, failed. Had a chunk out of it.
Who ate that?
So if that seal fails, air can get past, but not full air, only a little bit. That's why it was fluttering. But it did pressurize. It was fluttering. It didn't stop the air right there. It let air go on a little bit into the pot, so the pop-up was fluttering, but it did pressurize because these seals were good. So when the dead man trigger triggered, it did pop up and do its job and allowed air. The other thing is it never really wanted to fully depressurize because even when we let off the dead man and this dropped, air was still coming in as it was trying to escape. So it didn't want to fully depressurize in a quick manner.
So if you never would have closed that ball valve, it would have just sat there forever, pressurized, never depressurized it.
Just so happens we had one in stock.
And it doesn't take, once it takes a lot to pressurize it.
Here is, you want to change it?
Sure.
We'll put it back together and test it out. But you could see inside this how this valve needs to be. If you see these in the field over time, because of the nature, the abrasive air, you know, you could get these scored and then they won't work and you'll need a new valve body. But right now it's nice, smooth, new.
Any type of special torque settings or anything right here, just snug it up.
I think we use the good and tight method.
Good and tight.
Good and tight? Is that right? Is that right terminology, Aaron?
Good enough? Yep.
Good and tight.
So again, when you're putting that in, you'll want to look at these seals to make sure if those seals roll on you, then you'll have air leakage. So you want to make sure that those seals are facing opposite each other on the open end.
Do we provide lube in the, like, gasket lube at all in the rebuild kits?
We don't. The only time we put that lithium grease on there is if the valve's going to be sitting for a long time. So we'll put it on there from the factory because we don't know when the blast machine is going to be activated. But the only thing you need to do to lubricate it would be turn this petcock over, or you can put a couple drops of lightweight tool oil in your control lines, and that will lubricate the valve. That'll keep it system.
Yeah. There you go. Spring.
What's that? This piece?
Oh, yeah.
Like that or like that?
Wait, no, this is part of this.
Ah.
I thought you were looking for the cap. It's right there.
Ah.
What happens if you throw in extra parts?
The extra parts just get thrown away.
It gets more
Yeah. If there's extra parts, you throw them in the trash.
It's also very important that the logo is always facing up properly.
Yes, Sandy.
Just saying. It's more of a Curtis thing, but he's not here to say it. So.
Put this. Hernan used to have a mini impact for this job. Now we're all hand tools.
We can get it for the next group.
Took his tools home with him when he left. Take my tools home.
Old school.
Done playing.
So one thing you want to be careful of when you're putting the
They're in
screws
there.
back in, and you could use a power tool, but you got to remember the castings are aluminum, so as you're putting those steel screws in there, you can strip that body out pretty easily.
Put an impact on and drive it home.
Like a mini impact, low setting probably works. That's what.
So just make sure everything's lined up and you're not cross-threading when you're doing that.
You guys remember in the blast pop presentation, the lugs on the top for the umbrella? You can see in this, on this pot, the lugs are here. They have the pilot opening pre-cast in them. So, you know, with the kit for the umbrella, the field kit, you would take the right size drill bit and drill in to a certain depth. So there's a pilot hole already cast into
So they
there.
drill here and then just put your umbrella there.
Yep. Yeah, if this pot was sitting under a hopper or in a blast room setting where there's constant abrasive sitting there, you don't want that pop up to have to force that abrasive because you're going to wear out that.
Created some problems.
Yeah, the pop up and donut end. You need to have to get in there and change it. You've changed a tire or two.
Trying to sync with them a little
Cross tightening.
So by the time you've changed your inner lens in your helmet and fixed your belt, it's time to go home.
That's Canadian thinking right there. You're gonna have to work overtime and finish the job.
Well, then you got to calibrate your CO monitor.
Yeah, like your day's over.
The next day, you are ready to go.
That's right.
Better get some work done tomorrow.
Yeah. It's all preparation.
probably tight. Let's see. All right, let's see if it worked. No fluttering. I think you fixed it. Let's try it out. Pressurizes nicely, no fluttering. Let's see if it depressurizes. Boom, you fixed it. Easy field fix, right? You know, most contractors, if they have any of these pots with any of these valves, they're going to carry a rebuild kit in their toolbox. I mean, basic tools, you can get these pots back into operation pretty quickly. You just got to know a couple key things. Or you got to know someone that knows a couple key things. So let's move, we're going to move in here. Do this. Let's move in here and we'll try, we got four valves. We got 4 troubleshooting valves. Maybe you can guess by the weep hole action which seal kit needs to be changed. So this one, let's start on this one. We're going to give it air. And we got air at the dead man. We're going to trigger it, see if you can feel where it's leaking.
Right here? Yeah, right here. Through that hole.
That doesn't matter, this big hole?
Yeah, I think it's both. This one's both. This one has multiple problems, but it doesn't have an upper seal problem. All right. That one has multiple problems, but you could see, you know, with the weep holes, it helps you diagnose it in the field. Let's try this one. I'm going to plug that one in and trigger that one and see where that one's leaking.
Leaking there.
Same way.
Leaking around the roll.
Yeah. This one also has problems. Let's try the next one. See if this one's an upper. Yeah, that one's an upper. Yep. And then the last one. That one's a good valve. It does what it should do. So you'll see the difference. That's the Millennia valve. It's not as complicated as it looks at first.
So that dead man handle's supposed to make that noise all the time?
Yeah, that's a safety signal because you know if this dead man is leaking air, that this pot could be live at any time. You know, with some of our competitors, you don't know that. Schmidt, for instance, you could, you know, trigger their pot and you didn't realize that the pot was ready to go. If you hear it leaking out of this Clemco dead man,
It's ready to roll.
it's ready to roll. All you're doing is completing that circuit. And when you complete that circuit, actually air is always coming a little bit back to the valve, but when you complete the circuit, it gives it enough air to actuate it.
But still, I think probably the most popular deadman switch.
Yeah, and really the wear part on this Deadman is this bumper.
Yeah, you get the spring and the flapper.
Yeah.
On occasion.
You sell a lot of these little bumpers. If people are buying, Clemco control valves, they're going to want bumpers in stock because that's what wears out over time. And of course, rebuild kits for valves, abrasive trap screens. Those are good items to have in stock. I think that's it. I think we're going to move on to the classics.
So Joe taught us everything we need to know about contractor machines. We're going to take a look at the classic machine now. So you'll notice the classic machine has some different valving on it. So we looked at the Millennium valve, now we're going to look at our TLR systems. So the most popular type of system is going to have a piston inlet and piston outlet valve. So what we're seeing here, our piston inlet valve is a normally closed valve. So we can see that the valve right now is closed, so no air is going to get through this valve. As you release or press the Deadman, that valve is going to open. It's going to shift. At the same time, you've got air coming into your inlet valve and up through to your outlet valve. Your outlet valve is a normally open valve, so that's going to shift closed. So that's the most important thing you need to remember when we're troubleshooting our remote systems on our TLRs, is that our inlet valve is normally closed and our outlet valve is normally open. So if they're not shifting to the proper setting when they've got air pressure to them, then we know there's a problem. Any questions? Okay. We'll start with some troubleshooting here on this machine. Again, let's follow this air path that Joe kind of lined out for us. So we've got incoming air coming into our inlet valve. Again, we've got our control line from our Deadman. When we depress the Deadman, we're getting air from this portion here out to the Deadman handle. We press it and complete that circuit, and it comes back to the top side of our inlet valve. That shifts our inlet valve to open. Our air then follows this path up to our outlet valve. This one has a diaphragm outlet valve. That shifts that valve to closed. At that time, then the blast machine will pressurize and you'll be blasting. So what we're going to do now is I'm just going to turn this one on, and this one has a problem, so we need to figure out what's going on with this one. So we hear air leaking out of our handle, so we know it's okay to activate. Here it's not pressurizing. So if we go back,
I'm not helping you cheat. I'm not cheating for you.
yeah. So if we go back to yesterday, some of our early presentations, what was really important that we needed for our blast machine to be able to have enough air volume, equal pressure, and have enough volume to activate our pop-up and enough volume for the nozzle to be able to handle the blast.
What size nozzle you running?
Running a number 8 nozzle.
That's a big nozzle.
A big compressor for that.
So a big compressor and big airlines, right?
Oh, geez, yeah.
So we've got a little 3/4 airline on here. So that blast machine is trying to pressurize, but you'll hear it as it starts gaining pressure. You'll hear it build up. So it builds up, those valves are shifting, and then it loses pressure, and then it builds up again, those valves shift, and then it loses pressure and goes back to its normal state. So, let's see, I think we've got a smaller nozzle here. So, let's see what it does with the smaller nozzle that releases less air supply. Here it's still shifting, but it's building up pressure, so it's starting to seal. So eventually it'll get to where it'll still. So once that pop-up is up, then it'll hold the pressure even though it doesn't have the volume.
What size air hose is this one right now?
This is a 3/4. We're,
So that's okay to do what it was just doing?
no,
I mean, there's still something wrong.
no, well, yeah, there is. It's still undersized because it was still struggling to pressurize. So what we want our supply air hose 4 times the size of our nozzle orifice. So ideally, you're going to want a 1.25 inch, 1.25 inch air hose on this setup to 2 inches. So what we'll do, we'll hook up this other air hose. There you go. Thank you. All right, yep, so let's go. Let's point it that way. Give everybody a shower.
Off the ceiling on Joe's head again.
So you can see it pressurized a lot quicker. Are we losing air supply somewhere? Here, let me see real quick. All right, so we got an unexpected problem to troubleshoot. We're leaking somewhere here. Let me try this one more time, see if we got enough to. So you can tell the difference on how quickly it's pressurized. So one more thing I want to show you with the outlet valves is, I think I just don't have these fittings. I just hand tightened those. So the outlet valve kind of gives you an audible signal if air is passing by it. So what will happen is you'll have an operator that starts to get fatigued with their handle. So they'll be blasting. Maybe. Turn it off. That squeal is kind of an audible signal that you're losing control pressure. And what will happen actually with these diaphragms, they'll rear a hole. It looks like somebody took a drill bit and drilled a hole right through that diaphragm. But if you hear that squealing while they're blasting, it'll actually wear a hole right through the center. And then you'll need to replace your diaphragm. So if you ever hear it squealing, you want to go check your button bumper up on the handle to make sure that it's making a good connection. Or you'll want to check your control lines and then the diaphragm.
percentage of this particular powder sold with the diaphragm outlet valve versus the plunger style?
Typically your piston is the one that's going to be sold most. If you get into an aggressive media or something that is really hard on the outlet valve, we'll go to a diaphragm valve because it's a lot cheaper to replace the diaphragm than it is the whole valve body. So any fine medias that are going to get right through your outlet into the outlet valve.
But more specifically with the finer abrasive, you're saying?
Finer or very aggressive abrasive that's going to get in there.
So it's more aggressive.
Right. So anything that'll get past this abrasive trap screen into the outlet valve. Any questions on what we covered there? That's good because we've got a lot of problems with this next pot. So we'll set you guys up here and so one of the biggest keys to remember when you're troubleshooting these blast machines is that you're going to have one leak. And can anybody tell me where that one leak's going to be when you're blasting or when you're not blasting?
Handle.
Okay, so you're going to have one out of the dead man handle, and how about when you're blasting? Where's your leak?
The pit cock, right?
Coming out of your other leak will be the nozzle. So air will come out of either your dead man handle right here at the button bumper or out of your nozzle.
It should be.
Ideally.
Yeah.
So we'll get this set up, and we've got a few. I think maybe Chris put this pot together, so there might be a few things wrong with it
Real good job.
that we need to take a look at.
Get it on a Friday morning after
That's good.
All right. So go ahead, Dylan, and
Missing a blast hose and a nozzle.
we won't be able to determine our second leak. All right, so he found one. The petcock was open. The bumper's bad. Okay, go ahead and shut us down.
Obviously, because they got air
We'll switch out the handle.
on the inlet because the air has to be able to get in.
So the first thing Dylan noticed was he came over and somebody had opened up this petcock, so all of our air was escaping out of that petcock. So he shut that down, and then he depressed the handle here and noticed that there was a ton of air coming out of that handle. Still,
So you just replace the handle?
the button bumpers are really easy to pull out.
What is the point of the button bumper? What does it do?
So the button bumper is just a piece of rubber that's
Yeah.
going to seal this hole right here. So as you depress this comes down to that hole, seals the hole. So you've got your incoming source air through here, seals the hole, it completes that circuit and sends it back out to your valves.
So when it's open, then the air's just coming straight through here. Okay,
Right,
I
yep,
get it.
so it's leaking right out of that
Okay.
small hole right there.
Learn something else today.
These are the fun parts.
You kind of got to, like you say, you got to follow the air too, right?
Right.
To understand.
Right,
Then you throw the electric remote, that usually throws people off. Wait a minute, we're eliminating all this.
yep. So again, on these systems, there's no right or wrong way on where you put the air lines into.
Right.
So these valves, you can put your air line on either one, and same on their dead man handle. It's just one complete circuit that we're trying to complete. The other important thing to troubleshooting a blast machine is to make sure that you have a way to depressurize these machines. So when we don't have a blast hose on here, we'll put either this petcock down here or a muffler on there. So if you ever get into a situation where it's not depressurizing, we've got an outlet here to open and let that machine depressurize.
Do you guys recommend with a muffler to, maybe, and I've seen it, I'm trying to think more, not necessarily with your style of muffler, but I've seen guys that'll actually put a hose on it and extend it out.
Do a remote muffler. Yeah.
Do you
We'll,
recommend that? Don't recommend it?
yeah, that's fine. We do that a lot with our blast rooms.
Okay.
So your blast machine will be sitting outside the room and you want to depressurize it. You don't want it to depressurize around everybody that's walking around the room. So we run that right back into the room and it depressurizes in the room.
Yeah, a lot of times you'll see this in the bottom corner of a room somewhere.
Right.
We all set? All right, go ahead, Joe. Okay. So we got a couple things going on here. All right, so that was a good thing to do. So we're still pressurized, right? So what do you think's going on? We noticed that we're getting air out of here when we're trying to depressurize. We just depressurized.
No, when you pressurize, the air is coming out of there, right?
Yeah, when it was trying to pressure up, the air was.
Yeah, it was leaking air out of here.
And that should have been closed.
Right.
It's got a plunger, right?
That's correct. That's our piston valve.
If we don't, we'll rip that down.
Well, there's a couple things that could be wrong with it, and just to save a little time, I know there's nothing wrong with the valve, but another very common thing in the field is to have a blockage in this hose. So,
Just in the hose itself?
right. So what will happen is these hose ends are reusable, so you can take that hose end off and you can put a new one on. You can cut the hose. But as those hose ends are going on, the tighter you tighten this, the more it tends to swell. So you want it down tight, but you don't want to over tighten it on the hose. And when that hose end swells, when you put this portion in, it's got a barb in there, and that goes in and that'll actually grab a piece of that hose and create a blockage in there. So I just so happen to have another hose here that we could put on there.
Blow air through it, make sure it's good.
I'm guessing this one's good.
What'd you do to that one?
This one's got a blockage in this end here.
Did you put a blockage in there, though?
Yeah, Tom did.
So how would you know it's a
Did you actually
blockage
see
like
it though?
first without like checking this or that? Is there any way to do that?
I
So,
can see a little bit
the-
of light coming through.
Right. Typically, I would check the hose
I
first,
generally just put
so
my
make
eye
sure
on it
that that air's coming through it. But typically, you're going to check that and the outlet valve. All right. Boy, now we have to have everything by now, don't you think?
Oh, man. One more thing wrong.
Depends on who built it.
All right, Joe, go ahead. Sounds good. Sounds like our outlet valve's working. Boy, it's taking a long time to depressurize, isn't it?
That's got a lot to do with it, right?
What?
That's got a lot to do with it, right?
Yeah, they'll have a little bit, but we want the blast machine to rapidly exhaust through the exhaust valve. Has it dropped yet? Go ahead and shut us. All right, so we still have a problem. The outlet valve's working now, so that's good. It's closing and opening and allowing air to come back through. What else do you think could cause that? Hey, don't be sneaking through my box over there.
There's gotta be something wrong with
What-
the sand trap because we haven't done anything with
The,
that yet.
the abrasive trap, that'd be a good place to take a look.
I bet you the little cone in there is wrecked.
I would check in there.
I always say process of elimination. There's only 4 valves here.
A little clogged, huh?
All right, so
Looks a mess.
luckily I had one of these in stock that we could replace it with here real quick.
Is this even a real one?
No, it looks like
So what?
Is this a piece of metal?
someone else's part.
There's 2 of these here, and I'm gonna tell this story. So I typically don't do this presentation, but Tom Gear does. And I want to tell one of his stories that he tells in this presentation. So he said he actually went out to a job site and he was going to do a demo on a pipe tool, so a hollow blast or a spin blast. And before he could do that demo on the pipe tool, he had to fix their pot. It wouldn't depressurize. So they went through some of the same stuff that we just went through, and they opened up the abrasive trap. And he says he doesn't remember which one of these is the one that was actually out of that blast machine, but one of these 2 abrasive traps came out of that blast machine. The other one is one that he made himself. So this is actually an abrasive trap from a field.
Well, what's our sign that it was the abrasive trap though?
So the sign that you were seeing, and I think you hit it, was that we were getting a little bit of air through there, but it wasn't depressurizing. So that screen was blocked off enough to allow a little bit of air around it,
Okay.
but not enough to let that valve fully depressurize.
Same reason why shoving a bunch of steel wool in there would do the same thing. It doesn't allow any air, enough air to flow through.
All right, that's got to be.
Just a little bit of wool.
All right, so what do you guys think? Think we got it? No? No? Okay. One thing I didn't tell you, and I should have gone over this, so this is my fault, but I'm going to help you out here. So these valves have a metered amount of air that goes through the valves. So we meter that air through an orifice fitting on the inlet valve. So you'll notice when we pressurize this blast machine and you hear the air coming out of here, we've got a lot of air coming through this handle. So what's going on here is actually I've switched out this fitting here. This fitting should be an orifice fitting, and I put a full port fitting in there. So what's happening?
Smaller nipple.
What's happening is we're getting way too much volume to our valves to where that's not shifting. Let's see, I think I've got it in here actually.
Can you explain that? I'm not really sure I understand. There's too much air coming in, and so it's not allowing this to shift, you said?
So when we've got too much air coming through let me see that other fitting here real quick,
You want
Dylan.
a lot of air coming to here. But all these other...
So we want line pressure coming to this valve, but we want to meter the volume of air going to these valves. So if we have too much air going through the system, through our control system, it won't allow those valves to shift because we can't bleed enough air through our handle. So what happens was when we push down on it, it pressurizes fine, but it won't depressurize because we still have a good amount of residual air, enough air to keep these valves shifted so this one's still in its open position, this one's still in its closed position.
Constantly completing the circuit without depressurizing the handle because the volume of air.
So this sounded like it depressurized, but it didn't.
The pot did.
The Right.
There's a bunch of air coming out.
Right. You still had your pop-up valve was still up. And you'll notice once we get this changed out how quickly the machine depressurizes.
And the pop drops out. You're right, it does look like it's depressurizing here.
Right.
But if you look inside, it's never dropped down where you could add more abrasive. You see the port on that one he has in his hand?
Yeah.
What was the
different
difference
size?
in the ports that he had?
What's the other one
I
look
could see
like?
anybody in the field just switching out videos, just putting anything they want. Right? You know.
Strong one.
Hey, I had one of these in my toolbox.
Yep.
Definitely had problems.
Is there an external indicator?
Good. Sam's got the other one here.
Is there an external indicator that it would be a...
You know, we had at one point we had them different, so we've got a CAD plated and then we've got a brass. But you can't go by that anymore because the vendor changes and things we've had.
Is it always the fitting
Go down.
on the inlet valve?
Right. This is always the orifice fitting here, the one that's going out to your handle.
How about on here?
Same thing. Yep. Go ahead and give us some air supply, Chris. All right, so do you hear the difference?
It's not as loud, right?
Do we? What's going on now? I think we've got another problem.
No, it's not pressurizing.
So earlier we had too much air, which would allow this to pressurize. And so if we go back to my earlier conversation, how many leaks should we have in the control system? And one at the nozzle, and only one at one time, right? I hear two places that it's leaking right now. All right. So one thing you'll want to make sure of, and this kind of got us over there, but go ahead and just give it another quarter turn with the wrench when you get it hand tight, because you will get them tight enough by hand, but they'll loosen up as they get moved around. So just give it another quarter turn to get you completely tight. So I want to, Dylan, if you can, so do you hear the difference in the handle and how much more quiet? You'll start to pick that up as you go out there, and if you hear that really loud noise of air coming through, then you know that maybe we should check that fitting over there. Are we? All right.
Yeah.
Go ahead and let it depressurize. You guys comfortable with that?
Are you?
Am I?
Yeah.
I'm not the guy working on it.
We're finally depressurized.
We're depressurized. Ready to go home and have dinner?
And actually start work the next day.
All right, you guys, we got everything, so good job. I appreciate the...
Seems like a lot of air should be leaking through there anyway, you know?
Through the dead man? Yeah, it's got to bleed off a good amount of air, but with that orifice fitting in there, it cuts that air back quite a bit.
How smart are you guys that you're able to figure out this is going to fail first, but this other stuff will work.
I was happy
This
I
is going to fail next.
figured that one out right away.
That was good.
It's only
It's different every time, right?
I got a
we hit
question.
it with wrenches.
Yeah.
Why is he always opening and closing this thing?
So this will isolate the problem. So let's say you're blasting and this valve's not shifting. So what you could do is come over here and open this. If it's this problem to where you've got too much air going through the system, this would bleed it off, the blast machine would depressurize. If it's not, like we had a blockage here, then you got to dig into other portions of the valve. So that's why he was constantly coming over here and opening this, because he was trying to make sure that it wasn't an issue within the control circuit. So anytime you have an issue within the control circuit, you can open this up, it'll bleed it off, and the blast machine will depressurize.
But that has to be closed in order for the whole thing to work.
Right.
Okay.
So what's happening there is all of your air is going to come in to this valve up here, and instead of using all the air to force that piston down, with this open, all the air comes out of here, takes the path of least resistance, comes out of here and shuts down the system. All right, appreciate it, guys.
What would this fitting go to in our system?
This would be like the top side of our valves.
Doesn't it go on the little?
It could go in there.
That's what I was thinking.
So yeah,
That's what I
if you
was
had
thinking up over there.
if you had a different fitting up here, it could go in here. So
Goes
anything
on
that
the twin line, I think.
anything past the metered portion of the controls. Mm-hmm. Oh yeah, on the yep. Anything else? All right, I guess we can head back downstairs and